Oh,
Because I clicked leave meeting.
okay, good morning, everyone. Any questions from the homework? Please put your question on chat while I summarize what we did yesterday and the day before. Right. So a little bit of a summary, area between two curves. We can find the area either by taking vertical slices or by taking horizontal slices. And it will depend on the type of problem we have to decide which one we will. When we take vertical slices, we basically draw the graph as usual. We take the interval of concern AB and we divide the region into rectangle. By dividing the interval AB into pieces, we look for the area of a typical rectangle. Then we add up the sum of the area of a typical rectangle and we get a Riemann sum. Then we use the definition of definite integral to come up with the area. Every rectangle, its area is the value of the function at the upper minus the value of the lower function times a little bit of delta x. Now, integration with respect to y. In this case, we take horizontal slices. So we take the interval that we need to divide to cover all the regions of those rectangle, which is the CD. We divide it into those rectangles. We find the area of each one of them, which is for every y, the value at the right function minus the value of the left. We multiply it by the little delta y. In this case, y is my variable. It means everything will have to be expressed in terms of y. Okay. So this is a bit of summary. Now I go and look at your problem, and then we finalize the section today. So I'm seeing two problems on the board. Please, when I move a paper, and if you guys are not done, it's up to you to really tell me I'm not done. So I look at number 39. What is it about? 39. Okay. The region bounded by. So they want us to find the area of the region bounded by y equal e to the x, y equal e to the minus 2x, and the line x equal ln of 4. Okay. Now, any of those problems, there is one way, and one way to do that is first to sketch the graph. I have no idea what to do to do those problems otherwise. So this is my graph. Okay. Y equal ex. This is ex is one of those functions we should know. It's a graph. At 0, e to the 0 is 1. So it goes like this. That's e to the x. Y equal e to the minus 2x. At 0, it's 1. That's a negative. It means that's a decreasing. And it goes like this. It's always positive. X equal ln of 4. If this is ln of 4, whatever, put here ln of 4. X equal ln of 4, it means this region right here. So we need to find the graph, the area of this region. Okay, all right. So what we have to do is we have to take the interval from 0 to ln of 4 to here and divide into pieces. That's the interval we have to divide into pieces, and we cover the region with those rectangles. Now, in this problem, the upper curve is definitely very clear. I don't really have anything to do. So this is my upper curve. It's very clear, or the top curve. So my top curve is the EX. So very clear in this problem, there is nothing, to doubt. The bottom curve is also very clear. So the bottom curve here is e to the minus 2x. And we have the same. So as between the interval 0 and ln(4), the top curve is the same. There is no change, regardless where I take my rectangle. And the bottom curve is the same. There is no change. So there is no reason to divide or anything like that. So my typical rectangle, regardless where I take it, its length is e to the xi minus e to the minus 2xi. That's it. Okay. And the width here is my little delta x. Okay. So let's see what's the area. So the area is, that's one of the simplest possible scenario. Integral from 0 to ln(4) of my top curve, e to the x, minus the bottom curve, minus 2x dx. Right? So finding this area is really boiling down to calculating this integral. All right, now that's an integral we have to calculate. Let's see how we're going to do that. Antiderivative of ex, it's easy. It's ex. So I have no issue with this piece. Antiderivative of e minus 2x, that's a little bit more problematic because I have an inside function. So this one, I will have to do some kind of substitution. So I'm going to break the integral because I cannot do it immediately into two pieces, and I will evaluate each one by itself. So I will evaluate this one, e to the x dx. So I'm going to break it up. That's different, so I can break up, minus the integral from 0 to ln(4) e minus 2x dx equal to. Okay. The first one I have no problem with. It's ex between 0 and ln(4) minus. This one, I really don't know what it is. I need to have a substitution. So I'm going to do this here on this side. Okay, let me isolate that because I don't know how to do it on the top of my head. So integral from e to the minus 2x dx. I'm going to ignore the limit for a second and find the antiderivative of the indefinite integral. The only way I have to do it is I need to make a u substitution. So I'm going to put u to be minus 2x. The du will be minus 2 dx because that's what the derivative here. And so minus a half du is the dx. And this would be equal to minus a half antiderivative of e to the u du. Since I didn't put limit, I'm not changing limit, I have to go back to my original variable, e minus 2x. So finally, this is going to be that minus a half e to the minus 2x evaluated between 0 and ln(4). Right, so finally, I get e to the ln(4) minus e to the 0 minus a half e to the minus 2 ln(4) minus a half, it means plus a half e to the 0 equal to. All right, e to the ln(4) is equal to what? Quickly.
4.
E to the ln of x, give me x back. Done with that piece. Minus 1. Done with that. Minus, it's a plus. A half. Now, e to the minus 2 ln(4) is equal to what? Can anybody figure this out? Without a calculator. I mean, I know you can find this in the calculator fairly easy. Can anybody remember the algebra? Let's see.
1 over 16.
Why? Because minus 2 ln(4), this is 1 over e to the 2 ln of 4. All right, because I have a minus. Now, there are several ways to proceed at this stage. One way is to rewrite this. 2 ln of 4 is ln of 4 square. It means 1 over 4 square means 1 over 60. All right, so plus a half, 1/2 times 1 over 16, minus plus minus a half. And finally, I will have 3 minus a half plus 1 over 32, and I leave it to you to finalize the math. Okay, question before I proceed to the second one quickly, because we have a lot of actually problems to do today. Any question? Please feel free to ask. Right. So I look now at number 49. And if number 49, the integration is easy, I will leave the integration for you. If it's hard like this one, not hard, but if there is an extra step, I will do the integration whenever anything extra is required. So let's look at 39 now. I'm at 49. Okay, what's 49 about? The region bounded, sorry, by y equal x to the 2/3 and what? Y equal 4. Now I know on my lab you guys will have a small variation of this, but the basic idea is the same. So again, we need to graph. There is nothing I can do honestly without graphing. Okay. Right. Y equal x to the power 2/3. If we graph this, probably you may not know how to graph it, but if you guys use the calculator, that's going to look something like that. It's basically 2 pieces, okay? Now, y equal 4, this is a 4, and y equal to 4 is going to look that's y equal to 4. And those are symmetric, even though they don't really look symmetric here. If I draw a better graph, those 2 pieces are symmetric, but it doesn't really matter. And I need to find the region, the area of the region in between. Okay. So step number 1, usually we have to divide the intervals. To be able to know which interval I need to divide, I need to find the intersection point. So step 1, we find intersection point. The region in the first quadrant, because I rely on the book, and the book does not say, oh, okay, the first quadrant. That makes our life very easy. Thank you very much. If it's in the first quadrant, means this piece go. I mean, actually, honestly, it doesn't really matter. So this first quadrant means I have to get rid of this piece. And then I saw first quadrant. Okay, it means I need this one. Okay, that's my interval. But still, I need to find the intersection point. All right, I need to find the intersection point. Okay, so intersection point. So basically, I need to find when the function x 2/3. So I have to set up x 2/3. And I have to find out basically when it's equal to 4, because I need to find this intersection. I have to set up this is equal to 4 and solve for x. All right. How do you want me to solve for x here? Very quickly. If you are faced with this problem, how would you solve for x?
Raise it to the 3/2.
Okay, take both to the power 3/2. So we get rid of the 2/3, which give me x equal 4 to the power 3/2. 4 is 2 squared. It means 2 to the power 3, which is equal to 8. So this is 8. Okay, now to make sure, I just plug 8 back into here to make sure I get 4. Otherwise, I'm doing something wrong. 8 to the power 2/3 is actually 4. So I am doing the math correct. This is 4. Okay, so now I found my intersection point. So now that's the region. So the interval I have to divide into pieces to cover the whole region with rectangle is the interval from 0 to 4. Now, immediately we ask ourselves, do we have one upper curve? Do we have one lower curve? What's the situation? If I take my rectangle, and regardless where I take it within my region, this is my upper curve. So my upper curve or my top curve is 4. My lower curve, regardless where I am within my region, regardless where I am, this is going to be x to the power 2/3. So my problem does not require any division or anything like that. So this length, I call this xi. So this length here is very clear. It's the top value, which is a 4, minus the bottom value. That's the length. And everyone, the width is delta x. So again, the scenario is not complicated in here. So the area is the integral. The piece I need to divide is from 0 to 4. My upper, which is a 4, minus the lower, x to the power 2/3 dx. And within the region from 0 to 8, oh boy, and you are 100% correct, and I owe you an apology. Thank you very much. Thanks, Alan. All right, so it's equal to the antiderivative. Antiderivative of 4 is 4x minus antiderivative of x to the power 2/3 is 1 over 2/3 plus 1 x to the 2/3 plus 1. The whole thing evaluated between 0 and 8. So finally, I will get 4x minus 2/3 plus 1 is 5/3. Sorry. X to the power 2/3 plus 1 is 5/3. Evaluated between 0 and 8 equal, you do the math. Okay. Any questions? Anybody? Very good. All right, so I know I have number 63, which is standing there, and I promise you today I will do number 63. No question asked. All right, but before doing number 63, I actually have to go back and make sure we understand this piece very well. But as I said, I will do number 63. Do not even leave without I do it. All right, so I have to do at least few problems where this picture will become clear. All right, I did assign one problem. I will do that just to, it's easy, but I will do it just to make sure we are following everything. And once I'm done, I will give you mixed match problem where we have to decide which approach to use, horizontal or vertical. All right, so I will do one simple one, which is number 19 that I've assigned yesterday, I think, just to make sure we understand the horizontal thing. All right, so this is the graph in number 19. I have an upper curve. No, not an upper curve, my apology. I have one curve, which is this parabola, and I have a line. Okay, so this is my line, x equal to y. So already they're giving me x as a function of y. And this one is, the red one is what? X again, they're giving me x as a function of y, y squared minus 3. All right, and they are asking me to find the area in between. All right, so this is a problem where basically they are giving me both x as a function of y's, not the other way around, and I need to solve it. Question number 1. I'm going to take horizontal rectangle. So my question would be, if I take a horizontal rectangle. Okay, so in this case, I have to divide the interval, this interval, into pieces. So this is my intersection. I have to divide this interval on the y-axis into pieces to cover the whole region. So I definitely need to find the intersection point. Okay, that's problem number one. And we will do that. Second, if I take my horizontal rectangle, is the left curve and the right curve changing? Or I have one of them? What do you think? What's the left curve? What's the right curve? Let me ask a student because I feel I talk all the time by myself. Krish, are you with me? Krish,
Yes, I am.
okay, can you please tell me, is there a right curve? Is there a left curve? What can you say?
So the way I did it, I just did it with the top and bottom, so I can't really say. I did it with the vertical, not horizontal.
You will do it with top and bottom?
Yeah.
Okay. All right, that's an interesting. Now let me ask you the following question. If I do it with top and bottom,
Yep.
what's the top? What's the bottom?
The top I made, it was basically one of them was negative square root, the other one was positive square root for one half of it, and for the other half.
Very good. Do you need to split your region, yes or no?
For the vertical, yes.
Do you need to split the region?
Yes.
Absolutely. If we do top and bottom, let us be very careful. I don't want to mess up this picture. If we do top and bottom, which is I can do, no question asked. I'm not saying I can't, but let me tell you what's going to happen. This is the point here. I need to split right there. If I do top and bottom, I need to split right there. Right here, I have one scenario because the top will be the upper part of the parabola, and the bottom will be the lower part of the parabola. And then I will have to take another region here. If I take my rectangle here, the top is the parabola, the bottom is the line. So if I take those vertical slices, I can do that, but I need to split the region. Now the question is, because you will have to learn both, that's why I'm addressing those problems before 63. Is the right curve the same?
Yes.
What's going to be the right curve?
X equals to 2y.
Right. Do I need to split? It means if I take my rectangle here or here, regardless where I take it, will the right curve change any? Yes or no?
The right one, or are you talking about the left one or the right one again? Sorry.
The right one. I've said that the right one. Does it change?
The right one does not change.
Very good. What about the left one?
Yes, it does.
How? Where?
On the top area, it would be positive. Actually.
Everybody.
Does it not change?
It does not change. It always given by x equal y squared minus 3. If I am here, that's the right curve, x equal y squared minus 3. If I am here, what's the right curve? X equal y squared minus 3. So, left curve. So the left curve is always y squared minus 3, regardless where I have my rectangle. This is my left curve. It does not change. And this is my right curve. It does not change. So in a problem like this, in this particular problem, there are two reasons where taking horizontal make more sense. First, the right and the left are not changing through the problem, so I don't have to split. Second, they are giving me x as a function of y in both scenarios, so I don't have to solve for y as a function of x. Okay, before I go any further, any question? Because we will be doing that a lot. We will be doing both scenarios, and I want you to have full control over it. All right, so to do that,
Professor, can I?
Yes.
Oh, sorry.
Go ahead.
Can I see the other picture that you draw for splitting?
Here.
Yes. In here, when we calculated in the left side of the dashed line, if you like calculate the integral, then we subtract the bottom area from the top area. Am I correct?
Yeah, and how we do that? As your classmate said a minute ago, the graph was y squared minus 3, right? Am I right?
Yeah.
Yes. Then you have to solve for y. Because to take top from bottom, you need y as a function of x. Because you need the y value minus the y value. So it's going to give you x plus 3. It means my y is, and that's what Krish said, plus or minus x plus 3. In this case, the top one would be the square root of x plus 3. The bottom one with minus the square root of x plus 3. And then you have to take the value at the top minus the value at the bottom. Did I answer your question?
Let's see. So this is like because of we make two equation, we can find it with splitting. Like I got it, but
Okay.
thank you.
So now we're gonna do vertical. Sorry, we're gonna do those horizontal slices. So I need the intersection. Okay. In the previous problem, to find the intersection, I said the y from one curve equal to y to the other curve. But now in this problem, x is given as a function of y. So actually what I'm going to do, I'm going to set the x from the first. So I'm going to find the value of y such that the x value of the line equal the x value of the parabola. So instead of setting the axis, we can set the y to find the intersection point. Now we solve. Since it's a quadratic, the only way to solve is to make one side equal to 0 and proceed. Okay, now we factor, and we cannot factor, we use the quadratic. So we're going to use the quadratic formula. That's a 1 and that's a 3, y and y. It's going to be minus 3 and plus 1. Y squared minus 3y. So this will give me y plus 1 will give me y equal minus 1 and y equal to 3. So I found the y. So this point right here, that's the intersection. That's going to be the negative 1 in here. And the top one, I will get the 3. Now let me make sure I'm doing things correct. If y is minus 1, I plug it in the first curve, I get minus 2. If y is minus 1, I plug it here, I will get 1 minus 3, which is minus 2. So my intersection point is correct. Up here, if y is 3, plug it into the equation of a line, I get 6. If y is 3, plug it here, I'll get 9 minus 3, I get 6. This is correct. All right. So now the interval that I need to divide is actually this one. So it's not that, that's stupid on my part. That's right here. To cover the whole region, I need to divide this into. So that's my intersection point. So this is minus 1 all the way to 3. And now for each one, the length, so this is my delta y, absolutely here. And the length of every piece is always the value of the right, so that's the length, minus the value to the left. So now what's the area? And be careful in this scenario, because we divide the interval along the y-axis, my variable is y, it's not x. So be very careful, my variable is y. So the area is the integral from minus 1 to 3 of the right curve to y minus the left curve. That's represent the length of every rectangle times the dy. Be very careful, y is the variable. So when I split the interval, when I take horizontal slices and I split the integral along the y-axis, this is my delta y. Y is my variable, not x. Now the rest is fairly simple. The rest is simple. I get started and I leave the simple math for you. I first distribute plus 3 dy. Okay, this is equal to y is my variable. The integral cannot contain x and y. So this is going to give me 2 tan antiderivative of y is y squared over 2, and I have it y here, minus a third y cubed plus antiderivative of 3 is 3y. The whole thing between -1 and 3 of the problem. Okay. Question. All right. So this was a nice problem, and what's actually nice also about it, not because I did it this way, because if I've done it with respect to the x-axis, I will have to split. So doing it with respect to y actually saved me from splitting. So now I'm going to give you 2 or 3 scenarios, and each time I want you to tell me how would you like to do the problem, splitting across the x or the y-axis, and we will do it. So I'm going to give one fairly, relatively simple, close to the one I gave right here. So my question is, would you do integration with respect to x, with respect to y? Okay, and how we're going to do it. All right, so problems. Problem example 1. In this problem again, they gave you x as a function of y in a very clear way. Sometimes they mix match. One graph, x is a function of y, the other, y is a function of x. It is really up to us to fix. So let me start with the following example. Find the area which is bounded by the following curve. Y equal x square, sorry, x equal y square. So area bounded by area bounded by x equal y square, and the line y equal x minus 2. Watch very carefully. One curve, x a function of y, the other, y as a function of x. Y equal x minus 2, and that's a problem I did yesterday, actually, when I started the whole idea. That's my curve. Okay, now back to you. How would you like to do it? With respect to x, with respect to y, and justify. Okay, with respect to y, anybody agree with Sami? Kiana, what do you think? Okay, if a student doesn't answer immediately, I'll move on. I will not put them on the spot. Let me try the one I can read. Iana said yes. No, Alan said yes. All right. Yes, because again, for the same reason. If I do vertical, I need to split because the lower curve is changing. So we're gonna do horizontal. All right. If I want to do horizontal, so let me be very careful. This is x equal y square, and this is y equal x minus 2. So according to everybody, we're going to do horizontal slices. It means integration, y is my variable. Y is the variable. Okay. All right, y is my variable. So now we have to find a lot of things. We need the intersection point. Okay, and we need to find where what's the left curve and what's the right curve. All right. The left curve is this, it's the red one. I don't know why I painted in green again, but that's the left curve. So the left curve is x left equal y squared. Now, that's the right curve, y equal x minus 2. But this right curve, y is given as a function of x. And if I want, when I take those rectangles, to be able to have the length, I need the x value minus the x value here. So the first step, because y is given as a function of x, and I want to find, I want y my variable, I need to express x as a function of y. So step number 1, when I take y, the variable, X has to be expressed as a function of Y. So we're going to express X as a function of Y. All right, it's very easy. X is a function of Y for this curve. For that curve, we have Y equal X minus 2. It means X is Y plus 2. So step number 1, I need X as a function of Y because I'm working horizontally. Okay. So, and this will become my right curve. And this is unique. Regardless where I am, the right is Y plus 2, the left is Y squared. Okay, so the new thing here is we have to be very careful. And if we pick Y is the variable, X has to be given on a function of Y. So we have all ways to solve. And finally, what is my area? The area is equal to, oops, I need the intersection. To find the intersection, it's easy here to set the axes equal to each other. It means I set Y squared equal Y plus 2, and I solve, so that's the intersection. It means Y squared minus Y minus 2 equal to 0. I factor 1, 2, Y minus 2 plus 1. Okay, it means that this point right here is the Y value is the minus 1. And if I plug it in here, I get minus 1 plus 2, which is a 1. Plug it in here, that's a 1. And so that's really my bottom limit. My upper limit, be very careful, it's the Y that I'm solving for. Y equal to 2. If I plug it here, this is going to be 4. If I plug it here, this is going to be 4. The two axes are equal, my point is correct. And to cover this whole region, this will have to be it. Okay, so finally, my bound are, the area is the integral from minus 1 to 2 of the right curve, because I'm taking those vertical one, which is Y plus 2. That's the right curve, minus the left curve, which is the Y square dy. Everything have to be expressed in terms of Y, otherwise, and the rest is easy. So the rest is a half Y square plus 2Y minus a third Y cubed evaluated between minus 1 and 2. End of the problem. Okay, so the main new thing here in this particular problem is once we decided we want the vertical, the horizontal slices, every X has to be expressed in terms of Y. This was expressed already. This was not. Here, Y given a function of X, I need to solve for X in terms of Y. Because when I'm finding those lengths, I need the X value because I need the distance from here to here minus the distance from here to here. Okay? Please ask questions. You guys are too quiet. All right. Okay, I'm going to give you example number 2 and example number 3, and I will do number 63 and the same thing. So example number 2 is, I want to give you the following region. Region bounded by, so easy region. Y equal X squared and Y equal 9. Okay, and my question is vertical or horizontal. So that's Y equal X squared, Y equal to 9. Okay, I'm gonna pick one of you. Jonah, Madena, what do you think? Should we take vertical or horizontal and justify very quickly?
Probably horizontal because vertically you have to, no. Probably vertically. Respect to X.
But then make up your mind.
Respect to X.
With respect to X?
Yes.
Okay, because you're right, 100% correct. Right, you're right, because.
Because when you do it with respect to x, you do not have to split it into two sections like you would have to.
Yeah,
Otherwise,
so there is upper, lower. We don't have any question whatsoever. It's a very simple scenario, and y is given as a function of x as well. Okay, so there is no simple scenario. So definitely with respect to x. Okay, I have no issue whatsoever. And then the intersection point, x squared is 9, x is plus or minus 3. So this is going to be 3, 9, minus 3, 9. So that's the most simple scenario. There is nothing to it. So it's going to be the integral from minus 3 to 3 of 9 minus x squared dx. And the problem. Okay, now my last region. Okay, let me take it on a new sheet of paper, and then my last region is region bounded by. Okay, let me draw the graph. Y equal root x from the top, y equal root x, and the line y equal x plus 6. And this is y equal root x. And in the first quarter, and this line. So that's really the region I'm talking about. All right. I'm going to pick another student. Ian Perez. How would
Yes.
you do that?
I suppose I would find an intersection point so I could get my upper bound.
Okay, intersection point. Let's see. Okay, after, sorry, this is x minus 6. My apologies. Okay, and then
Set them equal to each other. Radical x equals x minus 6, I think.
yeah, you can do that. And then
Okay.
after that, let us say we found them. How would you
okay.
like to do them?
I would write the
respect-
integral from 0 to that intersection point, and then I would take radical x as my upper function minus x minus 6 as my lower function.
Do you guys agree with him?
Yes.
Okay. Anybody disagree? Anybody has issue? So Ian is telling me my upper curve. So he found this point. I'm not going to worry about it. Let's see if I can just look at. I'm not going to worry about it. Okay. That's not my issue here. He tells me that the upper curve, y equal root x, the lower curve is y equal x minus 6. Do you agree with him?
Yep.
Everybody, yes? Yes? Am I the only one who disagree?
what if you get to the x-axis? What happens there? I would probably go for left and right.
You go for what? What's the problem? You see this point right here?
Yeah, where x,
Right, what's this
where
point?
that second word.
Right, what's this point? Can we find can we find this point? This is the point when the line intersects the x-axis. It means to find it, we set equal to 0, x equal to 6. So this point is 6. Now, anybody has issue with that? If you go horizontal, we have to split. Absolutely correct. If you go horizontal, if we go vertical, we have to split. Why do we have to split? If I take my rectangle here, that's the upper curve. The lower curve is not the line. Are you with me?
Yeah,
You
I
guys
think
are
because the
quiet.
line is continuous.
What?
I think because the x minus 6 continuous.
Right. No, it doesn't
Correct.
just stop here. That's my curve. So between 0 and 6, the upper curve is root x, the lower curve is nothing more than the line y equal to 0. However, here, the upper curve is root x, the lower curve is the line x minus 6. So the lower curve is actually changing. So if I take vertical, I definitely have to split. Am I clear or not?
Yes.
Everybody? Okay, what about if I take horizontal? So I'm gonna now erase. So we can do it vertical. We have actually, you will have to do it sometimes both ways. But now I'm trying to make the idea. Now, if I take those vertical, do I need, okay, this point is 9. I don't wanna spend time on it because 9 minus 6 is 3. And this is 9. And this is 3, just to make our life a little bit. Now back to you. If I take those vertical, sorry, those horizontal, do I need to split the region? Yes or no? Back to you guys. All right, do I need to split? Okay, no, absolutely not. This will be always, regards where I take, this is my right curve, and this is my left curve. Regardless where I am, it doesn't really matter. And this is the line. So it actually easier, at least you will have one integral, not easier, but you will have one integral if we do the horizontal slices. So now we're going to take horizontal. Variable is 1. Now, when I decide to take y as a variable, what's the more important step I have to do? If I decide y is my variable, and this problem is actually not hard, what should I do now?
Write everything in terms of y.
Exactly. Express x in terms of y. Okay. And the rest is simple. So let's do that. We have two curves. Y is x minus 6. It means x is y plus 6. So this gives me x equal y plus 6. And x is, this is the right one. I solve for this one, y equal root x. It means x, that's the left one, equal to y squared. Everything has to be expressed. Okay, and now the rest is to set up my integral. So the area is going to become integral of the right curve, y plus 6, minus the left curve, which is y squared, the whole thing dy. Now my integral, to cover the whole region, I have to go from here all the way to here, from 0 all the way to 3. Remember, it's the y I am interested in, from 0 to 3. And of the problem. Okay. If I do it with respect to x, I have to split from 0 to 6. It will be square root of x minus 0, plus from 6 to 9, which will be square root of x minus 6, which is not bad, but I will have to split. Any questions? And finally, the famous number 63, which is, I hope by now should become much simpler than we have. So this is number 63. And this is my region. I have a parabola shape, which is y equal 9 minus x squared. I'm trying to color code it the way the book has it. I have this line, y equal 5 over 2x. and I have that curve, which is y equal 8x. And I have the region in between. Okay, so how are we going to find this area? All right. Again, we start thinking with respect to x, because all my y as given in a function of x, so I'm going to think about x is my variable. Means I have to think up and down. We have to think those vertical slices. Then I say, right here in this region, this is my upper curve, this is my lower curve. But if I am here, my upper curve is changing. My lower curve seems to remain the same, but it's my upper curve which is changing. And when does this change occur? This change is occurring right there. So this is going to be the dividing region. So I will have to divide into two regions. This is R1 and this is R2. Because the lower the same, the upper is changing. But to be able to do anything, I need to find the intersection point here. And I need to find the intersection. So I need two intersections. So I'm going to call this point A, and I'm going to call this point B. I'll find A. Okay. To find A, so intersection. First A. A is the intersection of the red, which is y equal 8x, and the black, which is 9 minus x squared. I have to set them equal. Since I have beginning of a quadratic, the only way to set them equal to each other to solve is I set equal to 0. So if I set equal to 0 and I bring the x squared here, I will have x squared plus 8x minus 9. Now I will factor out and solve. Okay, 9 and 8 will make me think of 1 and 9. I hope I'm not wrong. X plus minus. X squared plus 9 is going to give me x equal to 1. X equal minus 9. Minus 9 has to go. That's the point right there. Now, if I plug it here, I get 9. I get 8. If I plug it here, I get 8. That's my first intersection point. I do the same thing for B. It means I set 5 half x equal to 9 minus x squared. I solve for x. And if I do that, I think I will get 2. And then 5 from here, and I get 5. All right. And now I set up my integral very slowly. Before I set it up, I do. If x between 0 and 1, then my top curve is this red one, is 8x. My lower curve is the green, 5 over 2x. Okay, I totally split my problem. If x is between 1 and 2, my top is 9 minus x squared. My bottom is 5 over 2x. Okay, I seem to be taking 2 more minutes. I'm done. So what's going to be the total area? The integral from 0 to 1 dx plus the integral from 1 to 2. X is my variable here of that. The top is 8x. The bottom, 5 over 2x. The top, 9 minus x squared. The bottom, 5 over 2x. And of the problem. Okay, sorry for taking a few more minutes, but I want to make sure you guys get that. Any other question? Okay, of course, class is over. Remember, you have a quiz tomorrow as usual. Okay. Anybody has any question can stay online. The rest, you guys are free to go.